Okay, 611. And then we covered the substitution method, how that works. We ran through a bunch. And again, we certainly covered the graphing. We can get a solution that way. We can use the substitution method. That's out there. The elimination method. So I'm going to look at number 19 here. Okay, 19 says 4x minus y equals 3. And 2x minus y equals 7. Okay, and again, we're using the elimination method today. And of course, I mean, we know if we needed to use substitution method, I could write y equals whatever, plug it back into the other one, get my solution. I could certainly make my XY tables. I could graph this out and get my solution. But the elimination method works like this. And when you're using the elimination method, you want them in standard form. Okay? Different from when we were graphing and the substitution method, we wanted them, at least definitely for the substitution, we wanted at least one of them in slope-intercept form, y equals whatever, right? But when we're doing the elimination method, we want them in standard form here. And fortunately for us, every single one that they give us is in standard form already. So we don't have to fiddle around with any of these and rewrite them. So that's nice. But we want them in standard form. And then the whole key here is to use this, you add or subtract one equation from the other, right? Right here. This is all I have to say. They present these pretty clean to us here this year. Go back to the 14 and 16 problems that we did. We had to use some multiplying or dividing to kind of make the equation a little more clearer to understand. And that's the same deal with these. You can use multiplying and dividing, but it's not going to be necessary for any of these here. So what I'm saying here is if I look at these two equations here, and if I add them all together, 4x plus 2x is 6x, negative y plus negative y is negative 2y, 3 plus 7 is 10. So adding them wouldn't really get me anywhere, because what you want to do is when you add or subtract the two equations from each other, literally one, either the x or the y value should just disappear on you or be eliminated. So what I would probably want to do is subtract. And I'm just going to subtract this equation. So when we subtract, remember, it's like distributing a negative 1 through the whole thing, right? So if I rewrite this as an addition thing, so the first one doesn't change, but I'm going to subtract. So I'm just going to choose to rewrite it as an addition here. But I am subtracting. If I subtract 2x, that's subtract 2x. If I subtract y, that's a double negative, right? Double negative. Subtracting a negative means it's the same as adding. And then if I subtract 7, I just subtract 7. So in a sense, my 2x became negative 2x, my negative y became positive y, my positive 7 became a negative 7, right? But now, if I go ahead and subtract these two, or I guess I should say, what do I got? 4x minus 2x is 2x, and then negative y plus y is 0y. Anything times 0 is itself. Y is now gone. 3 minus 7 equals negative 4. And now, finish the equation. What does x equal? Negative 2. There it is. So now I know what x is. Now I can just go back to either equation, plug that value in, 4 times negative 2 is negative 8. And then negative 8 minus what equals positive 3? Be a negative 11. And same thing with here. Negative 2 times negative 2 is positive 4. And then positive 4 minus what equals 7? Did I write that right there? Right. Which one am I even looking at there? Negative 2, negative 11 is my thing. Did I write that right? Which one am I even looking at? 2x, oh, this was my 2x minus y equals 7 was my equation I started with. So 2 times negative 2 is negative 4. Minus y minus negative 11, double negative, 11 minus 4 equals 7. There's my solution right there. Let's try 21. So I got x minus y equals 6. 2x minus y equals 4. So adding the equations together won't remove anything. I'd have 3x minus 2y equals 10 if I add the two equations together. So that doesn't remove anything for me. So instead, and we can see right here, if I subtract the two equations from each other, what's going to happen? Again, the signs are going to flip, and I'll be able to just get rid of y. And then I'll just have x and just solve my one-step equation. There's my x, plug it in, find y. So once again, I'm going to want to subtract. So I'm just going to, and I can subtract either way. I mean, I can rewrite it this way if you so choose. But if I subtract this equation here, right, so subtract x, subtract negative y plus y, subtract 6, and again, notice what happens. I'm basically multiplying by everything 1, or I'm subtracting, or rewriting as an addition, flip all the signs, but when I subtract, just all the signs are going to flip. Negative, positive, negative. And now I can go ahead and add the two equations together. And literally, it's just going to tell you what x is. What is x?
Negative 2.
X equals negative 2. Boom. Plug it into either equation. What's y equal?
Would it be 4?
Negative 2 minus, I need to get a positive 6. I'm at negative 2.
Oh.
Negative 2 minus what equals 6. If you're not totally sure here, again, you can go back and rewrite in the form of y equals whatever, whatever, whatever. So let's just take this one, a little easier to work with here. X minus y equals 6. But I want to figure out what y is. I'm going to rewrite this for y. So subtract the x from both sides. Negative y equals negative x plus 6. And we're never ever solving for negative y, right? So multiply by everything by negative 1. So y equals x minus 6. Now what's y?
Would it be 4?
Negative 2 minus 6.
Or negative 4?
Negative 2 minus 6.
8.
Negative 2 minus 6.
Negative 8?
There you go. That's what y equals right there. That's my solution there. And if I plug it in here, 2 times negative 2 is negative 4 minus y, or minus a negative 8, double negative. 8 minus 4 equals 4. So there's my solution there. Negative 2, negative 8. Let's see. Do we got a good adding one here? Adding, of course, is a little easier. 23. There we go. There's an adding one there. It's all set for you right now. You don't have to mess around with the signs, reverse everything. This one's awesome. As easy as it's going to get. So these, since I already have a 3x and a negative 3x, if I just add these together right now, I should be able to figure out what y is right now without too much struggle. What's y? Y is 2, right? And now plug it into either one. If you need to rewrite the equation for x equals whatever, whatever, but these numbers shouldn't be too hard. And then what's x? So for my camera here, it's all set. I'm adding them up. 3x plus negative 3x. I'm basically just going to add the whole thing. 3x plus negative is 0x. So I've eliminated x. 2y plus 2y is 4y. 7 plus 1 is 8. Divide by 4, y equals 2. And then personally, I think this equation's a lot easier just to plug it into right here. Because 2 times y, 3x plus 2 times y, 4 equals 7. Subtract 4 from both sides. 3x equals 3. X equals 1. So therefore, my solution is 1, 2. What do you think? A little easier?
What?
Yeah, the subtracting, again, trying to rewrite the thing here. Try 25. 25 looks pretty nice and set up for you there. You should be able to solve for y. If I just add the two equations together. Once you know what your y is, you can plug it into either equation and got it? What is it?
Is it 2 and 5?
You solved for y, so your second value is going to be 2.
Oh, second one.
Because again, you should end up with 5y equals 10, right? Divide by 5, so that's my second number.
What was that second one?
So now my first number, my x value, Nick?
Is -5.
Negative 5.
Negative.
Right, and again, I can plug it into either one. I'll just do the top one here. Again, I didn't know this quite yet, but I know y is 2. So 4 times 2 is 8 equals 3. And again, all I did was just plug that in right there. Y is 2. 4 times 2 is 8. X plus 8 equals 3. Subtract 8. Here's my -5. And there's my answer to that one. Why don't you try 27? So this one here, obviously you can't add them together. That's just going to give you 9x minus 4y equals 49. That's not going to help you at all. So this is going to be a subtract one here. And of course, when you're subtracting, that means all the signs are going to flip. I'm subtracting. Subtract 4x. Subtract a negative 2y. Subtract 24. And then write whatever's left there. Should be solving for x. And once you got your x value, plug it in and solve for y. Subtract 4x, subtracting 2y, it's a double negative. Subtract 24, 5x minus 4x is x. Eliminated the y's, 25 minus 24, x equals 1. Yeah? And then plug it into either one. I'll just use that one, I guess. So 4 times 1 is 4, minus 2y equals 24. Subtract 4 from both sides, negative 2y, 24 minus 4 is 20. Divide by negative 2, y equals negative 10. There's my solution right there. On the quiz and stuff, I mean, I can kind of help you, but when you get into high school, the different problems lend that both methods have their time and place. Some problems are just much better suited to use elimination. Others are just much better set up to use substitution. In truth, I could use either one at any point, but most of them, and on the quiz and test, there's usually a much better option. I mean, you can use either one at any time, but depending on the type of problem and just is it in standard form, is it in slope-intercept form, that's one of your decision-making trees about which method should I use to solve this here. They both have a time and place, just depending on what the scenario is and what's easier for you to use. You don't really get too forced into use this method, use that method on quiz and test, but the problems, again, are written in a way that one method is clearly superior to the other to use. It's just kind of, I think you understand, like go back to the substitution, it's really helpful if it's in that y equals form right off the bat. That's what you want. If it's in the standard form, like all these, they're much better suited to use the elimination method. So, again, you'll get more experience with this in high school. A lot more practice using this type of stuff here, but truth is, I mean, they both are useful. It's just highly dependent on the format of the problem and which one is just going to be less work for you to solve with. Okay. Why don't we do, if it's all right, one more graph and then we'll call it a day. Is that okay? Okay. So again, if you're looking just real quickly at the homework, you see a couple of these here. We do not need a common denominator method if we're using the elimination method, because 1/4 minus 1/4, if I add these together, that's just gone. And ditto with this one too. That's a positive 1/5, negative 1/5. All I have to do is add them together and they'll eliminate each other. So when we were doing the substitution method though, we needed to rewrite it. We don't want to start trying to plug this and get all these fractional things all over the place here. It's going to make it much more difficult, so to say. But for your homework tonight, when you get to these two here, you don't need to rewrite these in any form here. They are all set literally to cancel each other out right now. So it's another one of those differences there, because 1/4 plus negative 1/4 is 0x. 2y equals 6 is what you got. Not trying to give it away to you or anything, but you know, that's all you have to do. We don't have to do what we did in the substitution method, where we need to, again, like these down here, we needed to resolve and clean this up here. So that's what we did. If anything, this one might have been more suited for the elimination method. All I needed to do was subtract 3x equals 6, x equals 2, right? Right. Subtract. 3y minus 3y is 0y, 6x minus 3x, 15 minus 9, x equals 2. Much faster than when we divided everything by 3, right? Rewrote two equations, this, that, and the other thing here. But you can see, like this one here would probably be much faster just to use the elimination method than the substitution method that we used. Because then we had to rewrite it in slope-intercept form as well. Y equals this. Well, I have all the work somewhere in here when we did it. I don't know where it is. Somewhere. One of these things. Oh, there it was, right there. There it all is. Yep, x equals 2. Remember, we did all this work here. See all that? We did all that work together there. We distributed all that and this, that, and the other thing. And when it was done, x equals 2, 1. But if we would have used elimination, 3x equals 6. X equals 2. So much faster, wouldn't it have been, to just use that in the first place? So you can see, again, there's a time and a place for both of these here. So, all right, one graph, and then we'll be out of here before 3:15. I'll just create one here, no, mega one here. Let's go with y equals negative x plus 4, and y equals 2x minus 5. And again, we're back to graphing, so that means we're going to need to get 3 coordinates for each, like such. Which one did I even pick? Okay, good. That's not too crazy of a one there. So I wrote them both in slope-intercept form for us. What you should do is think of 3x values for this equation, whatever you want them to be. Dot, dot, dot. Plug them in here. What does that equal for y? And then go to the second equation on your own. Think of 3 values for x. Dot, dot, dot. Plug them in there. Multiply them by 2, subtract 5. That's your y coordinate. And then graph out your 2 lines. Look for that point of intersection. And tomorrow we can check 6:11 and we'll get the last lesson of the chapter done, 6:12. Get to explore doing this with the inequalities. Takes a little getting used to, but if you understand this graphing stuff, because we're going to be doing heavy graphing again tomorrow. So if you can get your mind around how this works here and can get yourself good with the lines intersecting and all that, that will greatly help. So I'll fill in the values and graph, but Cord, this first one here, what are your three x values? You just tell me the x values, I'll get the y values.
X value, I got 1, 0, and -1.
All right, good choices. So if I plug it in, -1 plus 4 gives me a positive 3. 0 plus 4 is 4, and a negative, double negative, -1, that's positive 1. 1 plus 4 is 5. Those are your three coordinates. 1, 3. Or did you get double negative tripped up?
Yeah.
0, 4, -1, 5. So how'd you do with it, Nick? Good? You know, those double negatives, they're kind of thorny for you. They're not your friends.
Yeah.
Right. So that's how my graph here should look for this first equation here. And again, it's that double negative. You already have that negative in place. So whatever value you pick, when you're solving it, you're using the opposite. Because 1 is actually a -1 here, right? And then the -1, well, I already have a negative, so it's a -1. It's a double negative, which is a positive. 1 plus 4 is 5. Nick, what are your three x values for this one?
-1, 0, 1.
I like how you guys are rolling here. That's pretty much the same things I picked too. I keep it as small, as simple as possible. There's no reason to do it any other way. So -1 times positive 2 is -2. -2 minus 5 is -7. 2 times 0 is 0. 0 minus 5 is -5. 1, 2 times 1 is 2. 2 minus 5 is -3. So there's my coordinates that I have. -1, -7, way down here. 0, -5 is right there. And then 1, -3 is right there. I like it that they're not already intersecting. It makes it a little more exciting what the solution's going to be. Just not so fun when you, in my opinion, when you just roll upon it. But trying to be nice and precise here. There we go. Looks like we got a point of intersection right here. Looks like that point right there. So what's the coordinate that I ultimately landed on right there?
3, 1.
Right. 3, 1. That's my solution to it. 3, 1. Feel all right?
Yeah.
Cool. All right. So tomorrow, I don't know exactly